Program has been designed to help students with vectors. So the way it works out is students will be presented with a radar screen. Students will watch the progress of a plane across the screen. When the plane gets really close to one of the primary markings, it would be a good idea to pause. So the nose of the plane is what the student should be looking at. And they could see that the nose of the plane is 20 kilometers from the radar tower, and it's at an angle of about 20 degrees west of the north. Okay, students should write that down as position 1. They should resume the simulation. At this point, it's helpful to know that students can at any time turn the grid on and off. So if they're having trouble finding the plane, they can turn the grid off, and then when they get the plane in a spot that they like, they can turn the grid back on again. The student should be counting how many sweeps the radar screen makes between position 1, the one that they've already recorded, and the new position. I'm going to let this go for quite a while until it reaches, again, one of these primary distances. And in the meantime, I'll show you what else students can do. So students can have a printout of some graph paper similar to the radar screen, and I already labeled where my position 1 is. Again, it's 20 kilometers and it's at an angle of 20 degrees west of north. We then turn it into a triangle so we can find the X position and the Y position of the airplane. I let it go for 24 sweeps. And after 24 sweeps, it was right along the x-axis at a position of about 22 kilometers. Okay, I turn that 24 sweeps, since it's making 10 sweeps per minute, into 144 seconds. I then use position 1 and position 2 to figure out how far the plane traveled in the X direction, how far it traveled in the Y direction. You then make a triangle out of that. Get the actual distance traveled by the plane and the angle of the plane. Okay, we then find the velocity of the plane and put it into kilometers per hour. For heading, 0 degrees would be along the X-axis, just like in their math class. So the heading would be 180 plus another 51. So the plane has a heading of 231.1. Again, relative to the x-axis. Okay, once we have all our information, and you can see the plane is just about in that second position now. And again, when it gets to that position, students should pause it, write down their information, do all their math work. And there it is, right along the x-axis. Again, we're going from the nose of the plane, about 22 kilometers away from the radar tower. As you can see here, sweep frequency is 10 revolutions per minute. So with all that information, the students do their calculations. They then click on the End button. They can type in their name. They can type in their plane speed. Again, they want to put it into kilometers per hour. And they want to put in the plane heading, again with 0 degrees being the x-axis. The positive x-axis. Once they're happy with their numbers, they hit submit. You could see that I was off a little bit on my speeds and off a little bit on my direction of travel, but that's expected. We did estimates of angle and location, but again, it gives the students a good idea on how to do a velocity vector in a real life type of situation.